I slowly wind my way upwards on the washboard-like gravel road. When I reach the top, I suddenly push through the clouds. To be driving above a blanket of clouds is an out-of-world experience. On the Mauna Kea in Hawaii, it becomes very real. I'm visiting Gemini, which is run by 6 countries as a cooperative project. Partnership, not competition, is the core idea here. The setting sun, the glittering white and silver, patches of snow. The absurd ambience of these 12 observatories has a unique impact on me. Night after night, they look deep into the universe, listen to signs of life, driven by one of the oldest questions of our planet. Is anybody out there? Year in and year out, I've driven past the sign Meteorite Crater on this stretch of the highway in Arizona. 6 miles always seemed too much to interrupt my travels, and I was lacking imagination. Now, during my first visit, I'm deeply impressed. The crater is huge. It is said it could accommodate all of San Francisco's downtown.
Welcome to my backyard. If you like big holes in the ground, if you like the clean air, if you like the desert, this can be it.
Eduardo stands with a group of tourists at the edge of the crater.
So, I'll start with the crater history. About 50,000 years ago is when we believe that this happened. Our current theory is that it came in from the east at a 60-degree angle, traveling at this incredible speed of 26,000 miles an hour. The crater is 550 feet deep. The meteorite itself went through almost total disintegration. It obliterated, it fragmented, melted, vaporized, and ultimately it disintegrated. But the very first documented human interaction was a man by the name of Franklin Benitez, who was an army scout in the 1800s. It wasn't until this Hispanic shepherd, it wasn't until this Latino, oh, that's right, this year we're Latinos. Last year we were Hispanic. When I was in college, we were Chicanos. Now I'm totally confused. It wasn't until this Latino, Hispanic, Chicano kind of guy, we like to bounce a lot, found a good-sized chunk of what he thought was silver. Well, of course the guy keeps it. But when he decides to cash it in, have it analyzed, they discover it isn't silver at all. Okay, so now the chief geologist was the man by the name of G.K. Gilbert. Gilbert hears about the shepherd's find. He comes out here, looks at the crater, and concludes that this was a result of a volcano.
Since 1963, it has been accepted that this crater was not formed by a volcanic outbreak, but through a direct hit. A humongous wave of pressure is supposed to have devastated the countryside and killed all life within a radius of 3 miles. That happened 50,000 years ago. Measured in geological terms, yesterday. Believing naively that a fat iron meteorite must be lying at the bottom of the crater, Daniel M. Barringer bought the land sight unseen.
Way ahead of his time, dollar signs in his eyes. He goes back to Philadelphia. He forms Standard Iron Company. He goes to Washington. He files for 4 mining claims. He takes care of all the red tape to obtain the crater and comes back looking for the meteorite. He thought it was as big as the crater floor. He was going to smelter the iron and sell it to the railroad that was still being built as a businessman. But as a scientist, he was going to prove not only to his peers, but the world, that this was an impact crater and that impacts could really happen. Back then, you know what? People were not buying it. The idea of a rock falling out of the sky was as crazy as a man going to the moon.
The Apollo program finally got the Barringer meteorite crater the acknowledgement it deserved. If a crater is created by an impact, the inside will become the outside, and then you could just collect the stones without having to drill deep below the surface. Based on this knowledge, NASA trained future astronauts in the crater.
We have dark brown, we have light brown, we have white, and that forms the upper crust of the Earth. It's formed in a certain level, in a certain dimension, but everything is flipped over. In a volcanic crater, you would not have that flip over.
Not only for dealing with the moon, but also with the Earth, this finding was essential. Today, as has happened recently in Australia, meteorite craters are being located that have not been recognizable as craters for a long time, solely by the use of rock samples, rock strata deposited in the opposite order of the surroundings, and the absence of any volcanic rock.
You have a few skeptics, but I think 99% of the world believes that this was really caused by a meteorite and that rocks could fall out of the sky. Not only that, we know that it can happen again.
And this is what happens, only with much less effect. Meteorites, not huge asteroids.
When I was small, I used to look up to the sky, and my mom was very religious, and she would say, heaven is up there, God is up there, and that's where you're going when we die, blah, blah, blah. So now as an adult, as an older person, I look up to the sky, and I not only look at heaven, and I still believe in God, but I look at the stars, and I look at the meteorites, and I look at the asteroid belt, I look at the galaxy and the moon, and I know that there's something else up there besides heaven.
I feel a strong desire to touch a piece of the Diablo meteorite. Where else can you touch the sky? Meteorites, meteor showers, and shooting stars exude a very special fascination. What is out there beyond our knowledge? The rocks from out there are like witnesses from another world, and sometimes one can find them. For now, I try to find a place to stay. But the Wigwam Motel is deserted. Lawrence Garvey will introduce me to the vocabulary of meteorites. For example, how one defines fall and find.
The falls are, in a sense, the most valuable for science because they're the freshest. They've just fallen to the earth. You know, somebody sees this large, or many people see this large fireball event. It explodes in the upper atmosphere, and you know, they hear the big booming sounds, and it drops stones to the ground. And that happens all over the earth, randomly. A few times a year they're found and picked up. Maybe 8 or 9 falls are found per year. Now the finds are meteorites that you just find on the ground. Nobody saw it fall. It's just something you're wandering around out in the desert and you find a meteorite. That's a find. Nobody actually witnessed that fall.
Open house at Arizona State University. Once a year, everybody is allowed to touch a meteorite or to test whether a rock they bring is a found meteorite. Lawrence performs an experiment. At his side, self-made man Ruben Garcia.
I bring a garbage bag.
Then we'll just take one out at a time.
Let's go do that.
We'll take your calls.
I'm still excited.
Okay, I think that should be a large enough area. If you look at it now, see how nice and shiny it's getting? But you can still see the polish marks.
What's going to happen now is he's going to pour a very weak nitric alcohol mixture. As soon as he puts it on and sort of paints it on, it's either going to turn the specimen black, which will tell us it's man-made iron.
It's not a meteorite at all. No meteorites go black like that. Means that it's almost certainly not a meteorite.
I'm sorry, Chris, but it's not a meteorite, but like I told you in the beginning, we did all the tests and we have a nice piece of man-made iron.
I promise I'm not going to be mad.
You're not going to be angry?
So,
all right, well, thanks for bringing it in and we appreciate it.
Bad luck for Pavel Rockdell. His meteorite does not pass the test. Larry Zimmer, however, does own a true find. There's much joy and surprise.
And this is the sample. And if you look at it in the light, just move it around in the light, you can actually see all the little flecks of iron. And in fact, you can even see, you see these little round chondrules? You can just see the occasional chondrule in it. This is a beautiful meteorite, and you found this, didn't you?
Yes. Yes.
Thanks for bringing it in. And thank you. Go back out to the desert and find some more, please.
The study of meteorites is a young science which contributes to geology.
There's not very many universities probably that would have recognized the value of these things at the time, but that was right around the time when there was a lot of interest in space science. Sputnik just happened in the 1950s, late 1950s, and this was at the time when people were starting to think about space.
And it's really by a quirk of luck from the past that Harvey Nininger, who was one of the founding sort of fathers of meteorite collecting, was here in Arizona, and in the early 1900s to mid-1900s amassed an enormous collection of meteorites. He was based here in Arizona.
Basically, when I started my undergraduate studies, I realized that what really fascinated me was how does Earth as a planet work, and I realized I didn't really want to limit myself to the Earth. There's a whole solar system out there, planets out there. What are the big questions we ask? How did we come to be, and where do we come from? How did we originate? Where does what is the future of our planet? I mean, all of these are questions that actually, by studying these types of rocks, you can try to help to understand. And so, in a way, you're trying to really answer the biggest questions that humanity has.
In listening to Meenakshi Wadhwa, director of the Center for Meteorite Studies at ASU, I'm thinking, are we really stardust?
It's often asked is, how do we know this stone that I have in my hand is a meteorite? We could look at maybe if it's nickel-rich iron, we can be fairly certain because it has the characteristics of iron meteorites, for instance. But let's say we have something that doesn't necessarily look like a meteorite, but just looks like a normal fine-grained igneous rock, for instance. Well, the ultimate test is looking at radioactive isotopes that accumulate in the sample when it's outside the Earth's atmosphere in space. And in order to understand that, we have to understand what happens when we're in space. Space is bombarded by what are called galactic cosmic rays. These are like high energy, tiny bullets. They're protons that hit the stones in space, producing isotopes of elements that are not typically found on Earth in a large abundance. When we look at a meteorite, basically they're minerals, and they're built up of just a few minerals, primary minerals. We talk about olivine, that's the main mineral of the stony meteorites, and pyroxene, and nickel-rich iron. Those are the main things that we have in meteorites.
I'm asking Lawrence to tell me about the green mineral olivine.
This material represents the boundary between the core of an asteroid that had melted and the upper silicate materials. This is really this core boundary, the core crust boundary of one of those early asteroids. That's one of the theories that we have for these materials. But look how different these two look. This has got small, rounded green crystals in this metal matrix, and this has got these large, really large, angular clasts of olivine set in this beautiful iron matrix. So this one would have been heated to higher temperatures for longer periods of time, for instance, to get these tiny rounded crystals. Now actually the other thing to notice is the kaleidoscope of colors that we get. It looks like a stained glass window, look at that, when you look through it. See those beautiful, beautiful deep green olivine crystals that we see throughout the whole sample. And this is very unusual. There are very few pallasites that have this beautiful, these gemmy, opaque to transparent crystals.
Just fallen from above, you are the sky's eyes, Pablo Neruda wrote in his poem, Stones of the Sky. Not only poets, commercial visionaries became aware of the strange finds.
And actually, what people have actually done with some of these olivine crystals have actually taken them out and faceted them like gemstones. And here we have a beautiful example of a gemstone faceted from an extraterrestrial olivine. So this is an extraterrestrial gemstone. Absolutely fascinating.
And then the geologist turns into a magician. He carries me off into the miraculous world of science.
And if you imagine a meteorite falling in a jungle or a savanna region, like in the jungle, it's going to get lost in the leaf litter, and you're not going to find it. It's going to weather very rapidly because of the humidity and the rain. And you have a very short window of time to find it. Whereas if you imagine a meteorite falling in the desert, it's going to land on the sand or it's going to land on the rocks, and it's just going to sit there. It's a desert, nothing much is happening. So it's going to sit there for hundreds of years, thousands of years, or maybe even longer, waiting to be found, waiting to be collected.
The next day, we go meteorite hunting. We enter a somewhat dangerous area of the Sonora Desert. They're outfitted with golf clubs, pitted with magnets, snake protection on their legs, and pistols on their belts. Ruben also protects his face, but only against the searing sun.
Take a look at this.
It's interesting.
What do you think?
Definitely close. We should take it back to the lab and have a look at it.
Okay. It does stick.
Well, we might as well keep it anyway and not look at it later.
Okay.
Okay.
I'll hang on to it.
Hey, Ruben, look at this. Hey, look at this, Ruben. I think I found one. Look at this.
What'd you get? Oh, yeah, dude, you found one.
That's amazing, that is.
Look at that.
Must be at least 100 grams.
So don't touch it
No.
yet. Let's get a picture of it with you kind of pointing at it and
Sounds good.
excited about your find. Good job.
About the find, yeah.
Let
go
me
for
take
it.
a picture
Let's
of it.
photograph of that. Look how different it looks from the other rocks. Though.
Oh, it's
quite
way
amazing.
different. Look at compared to that one
I
and that
know,
one.
it's pretty
Oh.
obvious.
All right, I'm gonna get a picture of you after I do this, so don't move.
I cannot suppress a comment about these guys being armed. Sidearms to combat incoming meteorites?
It is not to protect against attacking meteorites, but I suppose if they did attack us, we could call them shooting stars. But in this case, we're both armed, and the reason is because this is a very well-known drug-running area. So we use guns to protect ourselves against maybe some bad people that we don't want to run into.
But the previous hunters found several bodies here and found people hiding in the washes around here and have found sort of drug bales in this particular area around here. So it's a very well-known area. It's a place we do have to be careful in.
Great job.
Back home in Scottsdale, Ruben saws a meteorite in half. I am reminded of an oyster, which is being shucked open to get to the pearl. And it is similar indeed. He shares with me his knowledge of meteorites, their hunters and their dealers. What is the value of a meteorite and why is it in demand? But I especially wonder why one destroys a precious meteorite by cutting and splitting it up.
Well, there's a couple of reasons that we would cut a meteorite, and one of the reasons is because the real beauty, the real magic happens on the inside of the meteorite. So we like to cut them to display that sort of hidden structure that you can't see on the exterior. And the other thing is, meteorites are one of the few things in the world that when you cut them, they become more valuable. So in this case, a meteorite that I purchased for maybe $1 a gram could be worth as much as $5 or $10 a gram once it's cut and prepared. All right, so now we've polished the end cut, and what we'd like to do now is reveal the crystalline structure that's inside. That's where the beauty really comes out. So we're going to be working with acid, and the acid is a very weak nitric alcohol mix, and just gently paint it on with regular strokes like you would, just like you're painting a meteorite here. And the crystalline structure begins to appear very quickly. Extraterrestrial. The pattern here is truly out of this world. No other irons will display this type of etch. So you could cut man-made iron and it just turns black when you put the etchant on it. But a meteorite, something from outer space, and the pattern is just otherworldly. It's amazing.
The acid treatment could reveal polygons, lamellas, or lines. The famous Widmanstätten figures are as manifold as the iron meteorites themselves. Sometimes they resemble city or country maps. Guides to another galaxy? How did Ruben, who has no formal education as a scientist, end up in the world of meteorites?
It was amazing. I used to be a composer, a musician, and I was sitting on the couch noodling around with my guitar, and on the TV shows a man walking through a desert swinging a metal detector, and I said, what is he doing? And he bends over and he picks up a meteorite about this size and says, oh, it's not worth much, it's worth about $2,000. I promised myself at that moment I would find a meteorite, and I did within 2 weeks. It can take months, maybe even years in some cases, to find a meteorite because it's not the easiest thing in the world to do. In fact, there's only about maybe 20 of us in the world that do this for a living. It's that hard. So, Ruben, we just got a letter from a guy that ordered something offline, and this is it. So I need you to pack it, and I'm going to have you ship it to that address, okay? There's a lot of interest in meteorites nowadays. It's always in the newspapers. There's always a fireball sighting. There's always a new bit of science coming from some of the meteorites we've already discovered and sold or donated to universities. So because it's so high profile, there's always a bit of news. And now with the advent of Twitter and Facebook and all the different sites that you could get online and see those things, it's always in your face, and you're always seeing something new and exciting from outer space. So these tiny little meteorites called Black Beauty are significant because of their rarity, which actually affects in a great way the value. So the meteorites are rare because even though they're Martian meteorites, they do not fit into any of the known categories for Martian meteorites. They have about 10 times more water in them than any other Martian meteorite ever discovered. That really affects value. For example, this little meteorite here in this hand is only 0.5 gram, but yet I value it at about $3,000. Now the bigger specimen here is valued at about $10,000. So rarity, in this case, very much equals value. This is one of my favorite pieces, and this is something that we affectionately call the Hammer of Thor. This came down as an iron meteorite. This fell somewhere in Morocco, and at some point, maybe hundreds of years ago in the past, a nomad picked this up and realized it was very heavy, almost 2 kilos, and he began using it, as you can see, as a hammer. So the tent stakes every night, or every time they would move their tent, he would pound the stakes in to the ground using the Hammer of Thor.
Signs from another world? Or messages to another world? They can hardly be seen from the ground. Does that explain why they were only discovered by a pilot flying over this territory in 1932? Nobody has yet solved the secret surrounding the 6 Blythe intaglios in California. It is speculated that they are 450 to 2,000 years old. Or were they created by a present-day forger who has had a good laugh watching us trying to find an explanation? Throughout America, A cult of meteorite hunters observes the landings of meteorites for real and on the net. Mike Henke, a member of the American Meteor Society, shows us an app he has developed. Mike is a software developer by profession, but a hobby astrophotographer at heart. In 2009, his photograph of the Mason-Dixon meteorite went viral around the world. Anyone who has seen a meteorite in the sky can share his findings with the help of the app. The app takes you step by step through a report about the fireball, and whoever wants to know where the meteorite comes from can continue on a multidimensional technology platform. It is important to stimulate the enthusiasm for science and technology, says Mike, because amateur astronomers and hobby astrophotographers make an enormous contribution to finding the rocks.
We have advanced applications to capture the visual recordings that people see, the mobile application that gets precise measurements out of the sky, and a network of camera operators that are running all sky cameras that actually record the camera, so that when a meteor does fall down, we can know the exact azimuth and the elevation angles, the perfect trajectory, and even the velocity of the meteor, look to the Doppler radar to find its location, and hopefully recover meteorites from it.
In Mike's dream for the future, all sky cameras are installed on each roof. Right now, he still has to rely on specialists such as the astronomer Peter Jenniskens.
And so when Sutter's Mill came down with a loud boom, we immediately knew that this was also a big rock that came in, and only 3 hours drive from where I lived. So this was very exciting. And so we immediately tried to find out, where did this thing land? Where could it have come down? And the first indication were the visual sightings that Mike collected. And so we immediately had a lot of people reporting that they saw this thing come in the Earth's atmosphere. And that's really interesting because it helps us determine where this meteorite came from.
A commission was set up. NASA came on board. Peter, who had already successfully managed similar research, coordinated the search operation.
It was such a shared experience. Everybody came out to the Sutter's Mill area to join in the search. We really had a second gold rush going on for a few weeks. This was phenomenal.
Robert Ward found the first meteorite. And then they all came and made Sutter's Mill a success.
This meteorite belonged to a very special class called carbonaceous chondrites, and those are related to Jupiter family comets. Those types of objects are what brought to the Earth the material that you are made out of.
Mike also found one of the sought-after pieces.
Within a few minutes of finding the Sutter's Mill meteorite, I really felt like I wanted to put it into a museum where a lot of people could see it and appreciate it, because I knew it was that special. Dr. Krupp?
Mr. Henke, welcome to Griffith Observatory.
Thank you. Here's my Sutter's Mill sample that I'd like to donate to the observatory.
Well, thank you very much. On behalf of Griffith Observatory, and really on behalf of the million visitors that come here every year and will see this in our California meteorite section, I tell you, I am very grateful. This is super.
Well, you're very welcome, and it's really my pleasure.
Super. You know, it is not every day that a meteorite drops out of the sky and hits the Earth and is recovered, and it's even less frequent that a meteorite comes directly to Griffith Observatory through a phone call from the person who found it. I was astounded by the message, and of course very pleased, and it was one of those things that you just don't expect to have happen. But I knew immediately when I got the message, and then when I took a look at the story, I knew it would be perfect at the observatory, because lots of people will see it, and it helps to amplify our story of meteorites in California.
Tucson, Arizona. Bob Haig lives here, the most prominent collector of them all. The millionaire has the largest private collection of meteorites in the world, and I could film it. For Bob, meteorites are a chance to feel the universe without having to leave Earth. And the alien visitors, as he politely calls the meteorites, help us to understand the entire planetary system, not only the planet on which we live. Bob is an enthusiast and the initiator of the boom.
I never realized that it would get so popular, but I think they're the coolest things in the world, and that's why I sleep above them, and I come in here at night and they talk to me and I talk to them, and it's kind of fun. I absolutely adore these stones. They're my friends. So I was always involved with rocks, but my mind and my heart was always on the stars. And when I learned about meteorites, I just took everything I knew from rocks and applied it to space rocks, and it worked. I found that the people that buy meteorites are people that really appreciate natural science. They appreciate shells and geometric forms, and people that like the stars, natural history, things, crystals, things of the earth. And this is a way they could hold something from the sky. In the old days, when I first started the meteorites, I was reading all the books at the library I could find, and everything was very old, back from the 30s, from Neininger, and there was really nothing modern about meteorites. It seemed like it went so far and stopped. And growing up with the minerals and crystals and the gem shows, the more I read, I realized there's more and more places to go and look for meteorites. So I would go to these places, something that fell 30 years ago or 20 years ago, and I'd make rewards. I'd use the media. I'd put advertising on radio at this little town in Mexico, or I'd make pieces of paper offering rewards, and I'd take them to someplace in Australia and go house to house offering to buy these stones. And whenever I was able to get some of them, no matter how much they cost, I could come back and keep the best one for my collection and sell the rest for a profit.
And he came up with a new idea.
The important scientific meteorites go to the important scientific people, but for all the rest of the world, everybody likes something beautiful and something that comes from outer space. Some of the meteorites have beautiful patterns and beautiful crystals inside of them. So I thought, why not start to make things out of them? So now we take meteorites and we make watches from some of the meteorites. Well, this is the Gibeon meteorite. Well, one of the coolest things we've made out of the Gibeon meteorite is, so we make the bar, chop it into little pieces, into little discs like these, and then I make this asteroid belt. So it's kind of like conchos from outer space. And it's a lot of fun. This is what Superman would wear, really. And it's something special. I mean, it's not like anything that comes from the stars.
With Bob and Robert Ward, I go back out to find meteorites. Will we succeed? What makes a meteorite hunter? Is it a job, or a vocation, or just a hobby?
Hey, there you are. Yeah, right on, man. Good to see you again. Yay, found you. There's a lot of area out here.
Sure.
This is the spot. I feel I got all the machines are ready to go, and the trucks are ready, and I think this is a good chance of finding the iron meteorite.
Well, this is actually the first time Bob and I have kind of put our knowledge together and exploring this region for more pieces of the Tucson meteorite. So this is kind of like the lost Dutchman of meteorites, and it's out here. We know it's out here. They found this big ring-shaped piece, and they found this cucumber-shaped piece, and we know there was another piece that there's photos of that was lost and buried somewhere beneath Tucson, and none of these pieces are the same shape. So that tells you that there's many, many more pieces of this meteorite out here.
The Tucson iron meteorite was found out here in the early 1700s. Probably the Indians knew where it was. And then the Spaniards found this perfect ring, and they dragged it in by horseback into the little town of Tucson, and they used it as an anvil there for the people to make horseshoes and things. And it was eventually taken by horses down to Guaymas and to the Smithsonian. But we know it was found in this area from all the old records and the maps. But exactly where, we're not sure. That's why we have to keep exploring. All right, you ready?
Let's do it.
All right, let's head it out, man.
Right on, brother.
Follow me, brother.
The meteorite hunters are cool. Somehow, they don't quite have both feet on the ground. But maybe you have to be like this if you want to reach for the stars.
It's a very dangerous area. Recently we had a fireball here in Arizona, and our team encountered drug runners several times. It's a dangerous area. Not only do you have to worry about the drug runners, but you also have to worry about law enforcement mistaking you for a drug runner. And you have rattlesnakes, mountain lion, bear.
Yeah, it's a long drive, but boy, this is worth it, dude. Well, this is the spot, I think. We searched all over these hills, and not very much here, so let's give it a shot, man. I've worked this area for 20 years, and I know I've searched this side, I've searched that side. Robert, where are the spots you've done?
Yeah, I've worked completely different areas,
right.
But it's just basically an investment. Every expedition's an investment because you're eliminating areas.
And we just scratch it off. That one's been searched, that one's been searched. Robert shares, we actually share a lot of information because there's a lot of miles to search here. And it's a lot more fun to search with your friends and your buddies. And you could walk this way and miss it. Robert walks that way and finds it. And so sometimes we share the booty.
So hopefully one of us finds one, and one of these days we'll make history.
That's right. And Robert's very good at this. So I've got more years at it, but he's catching up fast. He's right on my tail, man. I think he's maybe passing me. Since ancient times, it was associated with magical things falling out of the sky, so it had superpowers. One of the most interesting things about this treasure, which is what meteorites is if it falls into a country, it doesn't belong to that country. It's not from that country. It came from out of the sky. Robert! Wire. It's funny when you're hunting for meteorites and nobody finds anything, nobody cares. But when somebody discovers a meteorite worth priceless meteorite, everything changes. And everybody wants their fingers in the pie.
No one is spared, from the police, corruption, or both.
I was captured in the desert in the Sultanate of Oman with my partner at the time, and taken to Kurum Interrogation Center. And I was interrogated for days and taken to this blood-soaked interrogation room, and they would question me things like, "Are you scared?" And I'd say, "Yeah, I'm scared." "Why are you scared?" And I say, "Because I don't know why I'm here. I don't know what you people are going to do to me." And they took me back to the cell after that, and I'm laying there on the floor, and my heart rate's calmed down. I'm just not in absolute terror, and I'm like, okay, they're going to help me go home. And I started hearing these moans, like a dog howling. And I thought, well, maybe one of the prison dogs bit one of the guards or something. It's no care of mine. They're going to help me go home. And a short time later, the howls died down into whimpers and then cries, and suddenly I realized that was a human being.
Robert has created his own landscape. The large boulders lie not only in his garden or push up against the house, they also push through the floor into his house.
So this is all my backyard. I come out here every morning and take a hike when I'm home, and just come out and enjoy the outdoors. It's nice just to be able to walk out the back of my house and be out here in nature.
Wildlife, hunting, taming nature. His parents brought up Robert to live this kind of life early on. Safaris in Africa were also part of it. They stuffed Africa's big five they had bagged and put the trophies in the nursery. But today, the room with the hunted meteorites is the heart of the house.
Well, I purchased the land here in 2000 because of the boulders and the scenic nature of the property. When we built the house, I actually poured the pad around the native boulders. They're actually part of the rock formations outside the home. And I always wanted a house that had rocks. So when I found this lot, it was the ideal location to build my dream home. And these stones make a great meteorite display, and it's unique. It's not something you see every day.
Like many meteorite hunters, Robert comes from a family of mineralogists. But why meteorites?
It was actually my 10th birthday, and it was on my parents' driveway in Bullhead City, Arizona. And a large meteor was probably coming almost directly at me. And from my angle, it had a very short tail behind it. And the plasma around it, as it got into the lower atmosphere, started to dissipate. And soon there was just a cherry red glowing object that slowly faded to black. You could actually see the high and low areas on the meteorite relative to the fusion crust cooling. Probably 20 or 30 miles from me, but yet something from outer space actually hit the ground. So that really kind of, sparked that first initial interest in researching about meteorites, and eventually grew into a lifelong passion and traveling all over the planet in search of rocks from outer space. This is one of my most extraordinary specimens. This is Dhofar 1428. What makes this piece really extraordinary is the fact that it's flight oriented. When it came in through the atmosphere, it actually came in a stable fashion to where the leading edge of the meteorite has the flight-oriented regoliths leading away from the leading edge. So as this piece came through the atmosphere, it was totally stable like a bullet, and the particles ablated away the surface in a very particular fashion. It is truly an incredible collection piece. I actually found this piece. This was my second expedition to the Middle East, and I found that piece with binoculars, actually a couple kilometers away. I just saw this dark object in the light, against the white background, and drove over, and I didn't realize that this was extraordinary until I rolled it out of the sand, and then looking back at me is just this mind-blowing oriented nose cone.
It is rare that a meteorite of considerable size falls on a populated area. In February 2012, nearly 1,000 were injured when a meteor fell from the sky near Chelyabinsk in Russia. Thanks to smartphones, it could be seen on YouTube around the world seconds later.
phone's like blowing up in the middle of the night, and everybody's telling me there's this extraordinary event over Russia. It shattered windows, knocked people off their feet. So we knew that something really big had just happened. Well, I think at first they were, it was absolute terror. They didn't know if they were under attack or what was going on. It blew every window, nearly every window out of 8 different cities. It put, hundreds, thousands of people in the hospital. This was a very huge event. There was a lot of energy released. So I think at first it was absolute shock, but after they learned that it was a meteorite and they started finding stones, the public became interested in actually going out and finding pieces. So I immediately started making travel plans to get a visa and everything. Within 48 hours, everything was arranged. But then a very large snowstorm came in, so we were forced to wait until several months later when the snow started to recede. And there were hundreds of thousands of stones found from this event, as undoubtedly the largest meteorite hunt in history. So it was extraordinary to be a part of that and actually be there interacting with local citizens that are out finding stones, and to find many stones myself. I was there as the snow was receding, hunting field by field by field and collecting the stones you see right here in the case. So I was fortunate to find 19 stones, just under 3 kilos.
Every August, you can see the strikingly bright Perseids, the tears of Laurentius, falling from the sky. Excited by the meteorites, I'm on my way to the desert. I want to experience the meteor shower for myself, and maybe even catch a piece of heaven.
If you ask anybody in the general public, what would you want to know about the universe out there? Probably the question, is there life out there? Are we alone? And those are kind of fascinating questions that really space science and space exploration helps to answer. Space missions like Kepler, for example, are showing that there are many Earth-like planets out there at just the right place where you might have the right conditions for life to originate. And just statistically, I believe there has to be life out there. We haven't found it yet, but I'm sure, sometime in the future we will.
Meenakshi is confident. And I am too, at the end of my journey.